The second topic of this module is the arc length. We're going to proceed as follows. Instead of following through the natural flow of logic and deriving all the formulae from the firm mathematical foundation, we're going to take a shortcut. Here is the arc length formula, this one, and with no question asked, we're going to simply use this formula for at least one example problem. Master that skill, and probably in the next segment of the video, we're going to talk about its derivation from the natural flow of logic from firm mathematical foundation. The latter part is important, yes. However, a lot of students will find it very difficult to follow, and consequently, I'm making this compromise. Alright, let's study how to use this arc length formula with an example problem, and let's go with the first problem. X equals to e to the negative t power times cosine of pi of t, y equals to e to the negative t power times sine of pi of t, where t is moving from 0 to 4, and that can be visualized as follows. Here, when t equals to 0, we're going to get x equals to 1 and y equals to 0. Consequently, we get the right hand side endpoint 1, 0. And as t increases, the magnitude of x and y decrease because of this e to the negative t power. Consequently, the distance from the origin decreases, and the angle increases, and we have this kind of spiral. And we can calculate the arc length using computer algebra stem. Here, n-integrate command was used here. N-integrate, and then this is the integrand, square root of x prime of t squared plus y prime of t squared. And t is running from a to b, where a is 0 and b equals to 4. And let mathematical calculate it, and what do you get? We get 3.23652 approximately speaking. So if you do our computation correctly and then get a numerical value, this is what we expect. Okay, let's go back to our solution, and let me copy that arc length formula because this is something we are going to be using. T is running from a to b, and the integrand is square root of derivative of x squared plus derivative of y squared. So we need to start from the derivative computation. dx dt or x prime, dy dt or y prime. Here is the first step. The derivative computation, x prime, using the product rule and the chain rule. Y prime, the same way, product rule and the chain rule. These are elementary, and I'll trust you guys can do all these without too much trouble. After all, I assume everybody passed Calculus 1. Now, let's do further manipulation. We have to find out x prime squared and y prime squared. So before that, let's do this kind of manipulation. Let's factor e to the negative t power out. Here we go. We factored negative e to the negative t power out. Consequently, we have plus sign in the middle, and then the exponential part is gone from the second part. And what we do, let's square this. And squaring this exponential part, what do you get? We lose this negative sign and e to the negative 2t power. And then we're going to have this square of this bracket. We can do the same thing to y prime. We can factor e to the negative t power out. And consequently, we have this negative sign there because I took negative e to the negative t power out. Now let's square this y prime. Consequently, we lose this negative sign and e to the negative 2t power, and we have to square this bracket, and there goes y prime squared. And then let's add them up. We want x prime squared plus y prime squared. Excuse me. Before adding them up, let's break up all these parentheses or brackets. Cosine of pi of t plus pi times sine of pi t squared. I can use complete square formula, a squared plus 2ab plus b squared like this. Or you can FOIL it. And then how about y prime squared? The same deal. A squared minus 2ab plus b squared using the complete square formula like this. Or you can FOIL those if you want to. Finally, adding them up, what do you get? Exponential stay the same because that's common factor. You can factor those out. Now, cosine squared plus sine squared. What is it? We're supposed to have 1 by the Pythagorean identity. Next, 2 pi cosine times sine minus 2 pi cosine times sine. Add them up, we have 0. Third term, pi squared times sine squared plus pi squared times cosine squared. Factoring pi squared out, what do you get? Sine squared plus cosine squared, that's 1. So we have pi squared times 1. After simplification, what do we get? Exponential negative 2t power times 1 plus pi squared. This 1 plus pi squared is constant. Finally, let's take the square root. After all, we need the square root in the end. So take the square root, and e to the negative 2t power comes out of the square root as e to the negative t power. And this 1 plus pi squared will become square root of 1 plus pi squared, but that's not going to do too much because that's just a constant. And if we calculate the integral using that arc length formula, here we go. We have just e to the negative t power function times a constant. Constant just comes out. Here's the antiderivative. Apply the fundamental theorem of calculus, and then we have the answer like this. This right-hand side is the final answer, and this is a precise answer. Now, if you want to find out how large it is, you can use calculator to figure out, and it'll turn out we have the same value as we expected from an integrate command, 3.23652 approximately speaking. This, believe me, is typical problem, one of the easier problems regarding arc length problem. Nothing fancy took place here if you look at each individual step. We want this integrand, right? X prime squared plus y prime squared, and then take the square root of all that. So we need x prime, we need y prime here and there for the derivative computations, product rule and chain rule. And then square them and adding them up, well, that required a little bit of algebraic manipulation like factoring or complete square, but each individual steps were, well, elementary algebra or intermediate algebra at the very most. And then adding them all up, we need a little bit of trigonometric identities, but cosine squared plus sine squared equals 1 is such an important formula. I believe everybody should know this by heart. Whenever you see cosine squared, sine squared flying around, there got to be some kind of simplification. Indeed, there were. After that, calculating the integral at the very end was not much of a big deal. Well, how about another problem? Let's move on to problem C. And this thing is called a cycloid. This thing is called a cycloid of radius r. It can be visualized as follows. Let me minimize this program part. And then, well, let's see, here we go. We start with a certain circle with radius r, the same r you see over here and there. And then mark a point on the circle as this red point over here and roll it. And then resulting motion gives you this kind of trajectory, and t is moving from 0 to 2 pi, and that's gonna give you, whoops, oh come on, that's gonna give you the first arc here, starting from around here and ending there. So from 0 to 2 pi and back, we're looking for the arc length of this single arch of the cycloid. Okay, that was the visualization, and then let's work out the computation. We want the arc length formula, this one, whoops, we want this arc length formula, and t is running from 0 to 2 pi, alright, and then x and y are given like those, so we need the derivative x prime and y prime. And those are easy derivative computations. R this time is just constant, so take the derivative with respect to t and that's it. Now we want the integrand square root of x prime squared plus y prime squared, so square them, and we have r squared 1 plus cosine of t squared, and the t squared sine squared of t, and breaking up this complete square here, we get the next line like this: 1 minus 2 cosine of t plus cosine squared. And then do you see this simplification? Cosine squared plus sine squared equals to 1. Good. We have this manipulation so far. Now, is this simple enough to put into this formula over here and then take the antiderivative? Not just yet. The major problem is still the square root. Now here comes an ingenious observation. Let's apply a half angle formula backward, or power reduction formula backward. Increase the power. 2 minus 2 cosine of t can be rewritten as 4 times sine squared of half of t, as you can see over here. 2 minus 2 cosine of t is the same as 4 times sine squared t over 2. Consequently, we can pull the sine function outside this square root. We end up with this. In practice, you don't have to worry too much about this absolute value sign, because we are looking for an integral from 0 to 2 pi, the single arc of this single arch of this cycloid. When t is between 0 and 2 pi, t over 2 is between 0 and pi, consequently sine function is always positive there. The result? This integration. The integrand becomes 2r times sine of half of t, and we don't need absolute value sign. All you have to do is apply the antiderivative formula here, and then apply the fundamental theorem. Plug in 2 pi and then plug in 0, subtract one from the other, we get 8 times r. Consequently, we have this arc length formula here, arc length computation. Arc length of a single arch of a cycloid turns out to be 8 times the radius. And cycloid problem is very well-known problem for arc length computation, because this is one of very rare problem among those non-trivial curves that can be calculated precisely. Final challenge for this problem, according to this notebook, is this problem, and then I'm not going to spoil the fun, so I'm going to ask you to finish. And this is one of my all-time favorite, actually, because you'll have to calculate the derivatives using the fundamental theorem of calculus and the chain rule. The detail is left to the students.